Welcome to Modeling and Like Real-Time Simulation Movie. In this video we will show how the first of the three operative modes has been carried out for the Amazing Ball platform use case by means of the EICASLAB software suite. The goal of Modeling and Like Real-Time Simulation mode is to design and test the control strategies by using a simulator of the real plant to be controlled. In this use case, the plant to be controlled is represented by the Evidence Amazing Ball platform. For designing the plant model and the control strategies, we will use a standard desktop PC in which the EICASLAB software suite is installed. From the master window, we open the Amazing Ball project that we have already coded through the SimBuilder tool. In this way, the SimBuilder tool gets open and shows all the blocks that compose the project. The SimBuilder tool supports the developer during the first phase of the operative mode, the modeling of the system. The SimBuilder tool is an environment where the designer can develop the algorithms and the software related to plant modeling and control design. The tool provides three kinds of pre-organized working areas, specifically devoted and customized to program the different parts of the project. The first one is the plant area for modeling the plant to be controlled. The second one is the control area for the implementation of all the control algorithms. The third one is the mission area for the generation of control references and for modeling the disturbances acting on the plant. In our specific case, we have inserted four blocks. The first one is the continuous plant used for modeling the Amazing Ball platform. The block is programmed in ANSYS mode, and by clicking on it, we can directly access to the pre-organized structure of ANSYS files put at disposal by the SimBuilder tool for programming the block. Into this set of files we have inserted the code, including also the differential equation necessary for simulating accurately the Amazing Ball platform dynamic behavior. The second block is the control area, used for developing the control strategies and conceived to comply with different hardware and software architectures, including multiprocessors and multi-hierarchical level control systems. In fact, in EICASLAB, the control strategies can be organized in control functions belonging to the same processor and processor blocks that can be collected into processor network. In this case, we have allocated a processor block for representing the FlexDemo2 board of the Amazing Ball platform. By clicking on the block, a new layer gets open, showing all the implemented control functions. In this case, we have a single control function in which the strategies are programmed in ANSYS mode. The third and the fourth blocks are the mission areas, specifically devoted to model both the disturbances acting on the plate, disturbances that we have modeled graphically by using a simple library block for adding a white noise, and the user intervention that, for example, can change the desired trajectory. The last two blocks are the analog to digital and digital to analog converters. They enable the communication between analogical signals belonging to the plant area and the digital signals belonging to the control area, and vice versa. Once programmed all the blocks from the SimBuilder, it is possible to open the Activity Scheduling window for defining the order of the operation to be executed during the like real-time simulation. With the term like real-time, we intend a technique capable to accurately emulate in simulation the execution of the control architecture running in the final target. To correctly schedule the activities, the developer has to provide a simulation step, and for each blocks, the period, The duration and the phase as a function of the simulation step. Specifically, the period is the sampling period of the activity. The duration defines the execution time of the activity. The phase determines the time at which the activity starts with respect to the starting time. Once finished to model the system, it is possible to start the like real-time simulation phase. Through the master tool, we compile all the code and we launch the sim tool specifically devoted to manage the overall simulation phase. On the bottom of the sim graphical user interface, a control panel is available, including a button bar for starting, stopping, and time scaling the running simulation. It is important to underline that the timescale option acts in interaction with the like real-time scheduler, always guaranteeing the correctness of the simulation. In the middle of the screen there are 6 plotting areas, at which previously, during the modeling phase, we have connected the significant variables to be monitored during the simulation. Through the sim setting, it is then possible to set the initial and the final simulation time. Finally, if needed, it is possible to modify the project parameters by accessing at the sim builder in a special modality that froze the project structure but allows the parameters modification. At this point, we are ready to press the Start button for running the simulation. During the simulation, we can see the time running and the variable changing. For instance, in the first 2 areas, we can see the reference and the simulated position for both the 2 axes, while in the 4th and 5th areas, the commands calculated by the control function are displayed. By means of the 6 plotting areas, it is possible to get a sense of the trials, and for example, we can point out the intervention of the user that has changed the trajectory or the influence of the disturbances on the simulated position with respect to the desired one. When the simulation is completed, a more deep and accurate analysis on the trial's result can be performed by means of the POST tool, available in EICASLAB. The POST is the professional tool specifically conceived for performing the post-processing analysis of the data recorded during the like real-time simulations. During the modeling phase, through the SimBuilder tool, the developers can set up the EICASLAB for recording on the disk files containing all the variables of interest that allows the overall control tuning. Therefore, during the simulation, for each block a POST file is created containing the recorded values of each variable. Concluded the simulation, the POST tool can be used for opening this file and analyzing in detail the temporal trend of the recorded variables. Once analyzed the trials, the user can iterate the whole process by changing the control strategies or the planned model until he is satisfied. At this point, the modeling and like real-time simulation operative mode can be closed, and it is possible to switch towards the second operative mode, named Rapid Control Prototyping.
This webinar stops here. The next webinar will deal with the Rapid Control Prototyping operative mode, exploited for the Amazing Ball use case. Thank you for your attention. For any other information, please visit www.eicaslab.com.